So if we have to find all the zeros, we can first recognize this is quadratic, okay? And quadratics are easiest to solve if you can factor them, but there aren't two numbers that can multiply to be 6 but add up to be -3, okay? -6 times +1, that wouldn't work. -6 times -1, that makes +6, but it doesn't add up to -3. Can't find two numbers. But what we can do is we can use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Right? And so when we simplify, -3 makes a +3. That's 9 minus 6, that's 24. And we're going to get something imaginary in the numerator. So it's a complex number. Well, I mean, all numbers, I guess, are complex. That's square root of -15. So when you have a square root of a negative, you can rewrite it like this. That's the square root of 15 times I. I factored out a square root of -1 here. And the square root of -1 is I. Okay, so there's two solutions. You have one that's 3 plus the square root of 15i over 2, and you have 3 minus the square root of 15i over 2. So this has two imaginary zeros.